be easily covered up. Don't worry about that. So that's why मैंने आज polar triangle pick up नहीं किया, because polar triangle based question आने की probability is very very low. Okay. मैं जो आज पिकअप करने वाला हूँ आपके साथ, द टॉपिक विच वी आर गोइंग टू पिक अप इज कॉम्पोजिट सेलिंग. सो पहले मैं कॉम्पोजिट सेलिंग पिकअप करूंगा. वी विल अंडरस्टैंड व्हाट इज द कॉन्सेप्ट बिहाइंड इट एंड वी विल सी कि इसको हम सॉल्व कैसे करते हैं यूजिंग द स्फेरिकल ट्रिग्नोमेट्री. एंड once we are done with composite sailing, there is one typical kind of problem which comes there. So मैं वो भी आपको explain करूंगा. That comes quite a bit, where the limiting latitude matches with one of the ports. So ये दोनों discuss करेंगे. That will complete our composite sailing. फिर once the composite sailing is complete, तो आप जो मैंने assignment आपको भेजी है, you will be able to complete the full assignment. Okay, so that's number one thing which we are going to do. इसको complete करने के बाद we will move on to basically practical navigation. उसको भी मैं बहुत basic stuff से शुरू करूँगा. We will do plane and parallel sailing today. Plane and parallel and Mercator, though they are very very basic, they are done in second mates level, and in phase 1 usually nobody touches them, but still I would go through them. If there are any doubts, that should be clear in your mind, because any mistakes made in those basics are going to result into bigger mistakes and losing of marks. So that is the plan for today, beta. Okay. You can write basically in degrees, minutes and decimal of a minute, or you can write in degree, minute and second also. The calculator will give you degree, minute and second. You can write in that format also. Avoid writing in degrees and decimal of a degree. Yes. That's perfect. That's fine, beta. That's fine. Because most of the questions are solved. अगर आप book के question के साथ match करोगे तो they are solved using tables. You are solving them with calculator, so there could be a little bit of difference. That's fine. That's not an issue. Beta, if you are that comfortable with 4 parts formula, you can go ahead. You can do that. Okay. But if you, it is very much acceptable. It is acceptable. If you are comfortable with it, you can go ahead and do it. If you feel any doubt or any confusion in applying that formula, then you switch over to the method which I have given. I basically prefer the easiest possible methods. Okay. Okay. So if you are comfortable with 4 parts, you just go ahead. That's perfectly in order.
Okay, sir, we'll start.
Okay, great.
Sir, I have some one doubt, sir.
Go ahead.
Regarding how to locating the positions on the grades, like from A to B, sir, from while traveling from west to east and east to west. I have some problem for that diagrammatic imagination.
Okay, you have a problem. Is there a particular question where you are facing problem, beta?
So number 2, sir. Not in that book that you given in that slideshow. Number 2 slide.
The screenshot which I sent you.
Yeah, screenshot. Number 2
question. Okay, yeah. I will just open it up, beta. Give me a minute. I'll show you here.
So basically, just give us a basic how to plot when we are going from west to east or east to west, so that it will be in our mind till till exams or whenever.
Okay, beta, I got it. I got it. In this number two question, basically the अब बेटा इसमें जो इशू है, वी आर बेसिकली क्रॉसिंग 180 डिग्री मेरिडियन, राइट?
So I have some problem in imagining that, sir. For the
नो प्रॉब्लम
imagination.
बेटा, I'll explain you. I'll explain you. 180
Sure, sir.
डिग्री मेरिडियन क्रॉस करने के टाइम पे, सी इन दिस क्वेश्चन वी आर क्रॉसिंग 180 डिग्री मेरिडियन. सो अच्छा बेटा, पहले मुझे ये बताओ, you are starting from 165 west and you are going to 155 east. Can you tell me the direction of the D long? Are we
D
going in
long
the...
will be east. East. We are going more to east.
Very good, beta. I had sent a small snapshot of the PRACNAV D long calculation. Did you go through it, beta? Okay.
Gone through that.
So you can refer to that screenshot which I sent you. It says when the longitudes are of opposite name, the D long is obtained by adding them or subtracting them.
Adding them.
Very good. So you add 165 and 155, right?
Yeah.
What is the answer which you get?
It is 40.
Beta, 165 plus 155.
Okay, that one. Okay. It was 320. So.
Very good. The answer which you are getting is 320, right?
Yeah, yeah.
Okay. Now this 320 is greater than 180.
Yeah.
Okay. Let me write it here. 165 west and you are going to 155 east. So both are of opposite name, so you add them, and when you add them you get an answer of 320, right?
Yes.
Very good. And what will be the direction of the D long, beta? West to east. What will be the direction?
East.
It will be easterly. Now this value 320 is greater than 180. Whenever the value is greater than 180, what do we do?
We'll minus 360 and opposite sign.
Very good. So when you subtract it from 360, the answer which you get is 40 degrees. And what is the direction which you get?
West.
Very good. That means you are going 40 degree in the westerly direction, right?
Okay. 40 degree to the westerly direction.
Right. Now westerly direction is always the left direction in the diagram, beta. You see the ship is moving in the left direction, westerly direction.
Westerly. Okay.
Right? Are you able to visualize it now?
Yeah. My doubt is, sir, before that, east, this is east, this is west. So how it is? Now it is I understand, sir. I understand now.
Sir,
So we
so
are going
basically,
40 east. Okay. 40 west. Okay.
Right.
sir, so
beta,
basically, sir, whenever this type of thing is coming, so we need to find out the D long first. If it is coming normal east, that is less than 180, so direction will be same as the direction which from west to east. What is coming the D long direction? If it is coming more than 180, we need to subtract and direction will be opposite. Correct, sir?
Exactly, beta. You find out the D long, get its direction, and you make the diagram basis the direction of the D long. It will always be correct.
Okay, so copy that.
Okay, all right.
So what is the cosine formula for finding the when we have three angles known?
Okay, beta, with three angles known, cosine formula does not apply. Cosine formula is only applicable in two conditions. One, where three sides are known to you, and number two, where any two sides and the included angle is known to you. In case of three angles, we will have to use some other method, beta.
Okay, sir. Thank you, sir.
Okay. But usually in usual questions that will not be required.
Okay, thank you, sir.
Okay, beta. Great. So for now, doubts sorted out. Can we move on to composite sailing?
Yes, sir. Yes, please.
Yes, sir. Yes, sir.
Very good, beta. Great. So for composite sailing, I'm going to show you the composite sailing concept through a video. So I'll show you one video. We will understand what composite sailing is. You will see a question being solved also. So let me set up the video for you. Somebody is struggling for a link for joining. Okay, let me send it, beta. Okay, all right. Okay, beta. I hope you can see my screen now.
Yes, sir. We can see. Let us also review concept of.
Very good, beta. Great. So we are now going to start off with the concept of composite sailing. Let's go.
We brush up our concepts of parallel sailing, which I'm sure all of us are aware of. Now, when a vessel sails along a given parallel of latitude, that means along an easterly course that is 090 degrees true, or a westerly course that is 270 degrees true, the sailing is referred to as parallel sailing. We already know why it's called parallel sailing, because you're moving along a given parallel of latitude. Now, departure is the east-west distance between two places expressed in nautical miles. So please note, it has to be expressed in nautical miles, and it needs to be the east-west distance between the two places or points. Now we have a parallel sailing formula, which gives us a relationship between d long and departure, and we all know it. Cosine of latitude is equal to departure upon d long.
Okay, beta. So this is the parallel sailing formula. Whenever we are moving along the parallel of a latitude, that means moving easterly or westerly, we can calculate our distance using this formula. Departure obtained from the formula is the distance covered on the parallel track. So cos of latitude is equal to departure upon d long, or departure is equal to d long into cos of latitude. So any doubt up to this place, beta, up to here?
So is this cos latitude or cos mean latitude?
Beta, if you are doing parallel sailing, latitude and mean latitude both will be same. When we are doing plain sailing, then it is mean latitude.
Okay, so understood.
Okay.
Sir, departure means the distance between initial and final position, right?
That is right, beta. When you are doing parallel sailing, departure is the actual distance covered.
Okay.
Okay, very good. So this is the formula which we will be using in composite sailing. departure is equal to d long into cos of latitude, or cos latitude is equal to departure upon d long. Very good. So moving ahead now.
Obviously, this cos lat cosine is a trigonometric ratio. So obviously the units of departure and d long will be same. So here we have the world map on the screen. Let us say we need to depart Tokyo in Japan, which comes up on the screen marked as point A, with its coordinates also showing up. And we need to reach Seattle in United States, which also comes up on the map marked as point B, with coordinates of the Seattle also showing up on the screen. Obviously, our preferred route shall be great circle sailing to save on time. And in this case, you can see it shall be across the 180th meridian, across Pacific on an easterly track. Now let us quickly draw a PAB triangle between Tokyo and Seattle on the globe. Here we have point A representing Tokyo. Here we have point B, Seattle in United States. We join them with a shorter arc of great circle. So this is from A to B, the arc great circle track between A and B. This is the vertex of this great circle track. So we have the GC track from A to B as well as the vertex of this track. Now we can see in this case the GC track is easterly because the D long from A to B is easterly. Let's now draw the meridians of A and B. So the two meridians come up on the diagram, and what we get is a PAB spherical triangle, which we all know that if enough information is available, can be solved. Now this white track out here is the rhumb line track between the two locations.
Okay, beta. So now what you see on the screen is a actual PAB triangle on the surface of the Earth. P is the pole, in this case the North Pole. A is our starting position, that is Tokyo, and P is our destination position, that is Seattle. So we have shown the great circle track also. We have shown meridian of A, meridian of B also. Any doubt up to here, beta?
No, sir.
Very good. Let's go ahead.
And we can see that the rhumb line distance obviously is greater than the GC track, and therefore the preferred track shall be the GC track from A to B. For the sake of clarity, let us see how these two tracks, that is the GC track and the rhumb line track, would appear on a Mercator chart. Now this is how the tracks would appear on a Mercator chart. On Mercator chart, the GC track would be a curved track and a rhumb line track would be a straight line track. We all know that on Mercator charts, because the meridians are parallel straight lines, therefore the rhumb line tracks are straight lines. Now here it may appear that GC track is a longer distance, but that is not so. It is the GC distance along the GC track which shall be the shortest distance. How would these two tracks look on a mnemonic chart? Let's look at that. Now here we have how it would look on a mnemonic chart. On a mnemonic chart, it's polar mnemonic. GC track would be a straight line and rhumb line track would be a curved track. So hope these two comparisons also bring in clarity.
Okay, beta. So this is just for your understanding, conceptual understanding, not that we require them in our solution, but just to show you how a GC track and a rhumb line track appears on a Mercator projection and a mnemonic projection.
About how these tracks appear on different projections. Now, having appreciated as to how these tracks appear on different projections, we come to the most important part of our discussion. And for that, we go back to the PAB spherical triangle constructed between Tokyo and Seattle a while back. Now on this globe, we can see this PAB triangle, with this one being the GC track between A and B. On examining this track, what do we see in this part of the track? We see that some part of the track appears to be passing over land or maybe non-navigable waters. Now, this could be one reason, or there can be other contributory factors also, which may force a vessel to decide on the highest latitude that it would not like to cross during her voyage. The highest latitude that the vessel would like to reach and not cross is referred to as limiting latitude. Let us say, factoring in all the requirements, in our case, let us say we decide to limit the latitude to 50 degrees north. Here comes the parallel of latitude of 50 degrees north, and now obviously it's very clear that the vessel cannot go from A to B along the GC track because some part of it is crossing the limiting latitude.
So beta, this limiting latitude basically helps us to keep the vessel in safe waters. If we are going into any dangerous waters or passing over land, we limit our latitude to a particular parallel. So up to here, any doubt beta?
So sir, in this diagram, the GC track where it is cutting initially the limiting latitude, that will be the first part where we stop our GC, correct?
No beta, no, we will not do like that. We will move on a separate GC track. I'll show you.
In such cases, to strike a balance between the shortest possible distance and also meeting the requirements of not crossing the limiting latitude, the vessel may use combination of sailing. In this case, combination of great circle sailing and parallel sailing. What does the vessel do? Vessel figures out a GC track whose features include A, it passes through departure position A. 2, it has its vertex on the limiting latitude. So here is the GC track passing through A with its vertex being here on the limiting latitude. V1 represents the vertex of this blue GC track AV1. Now this is a GC track obviously. This is the meridian of V1, the vertex. We all know that this meridian will make an angle of 90 degrees at V1. So what do we get? We get this shaded right angled spherical triangle. PV1A is a right angled spherical triangle.
Now you look here beta, you can look if you pay attention. We have altogether left the initial great circle track. We are not following it anymore. Pink color great circle track is not being followed at all. We are following a new track, the blue color track, and that track is Alpha Victor 1. What is this new track? It passes from our initial position A and it has its vertex on the limiting latitude 50 degrees north. So we are totally going on a brand new track, Alpha Victor 1.
Sir, how do we decide on this limiting latitude?
Beta, practically on board, in MMD questions, there is no issue. They will give you the limiting latitude. Practically on board, this is decided using different sources of information like a routing chart, sailing directions, or weather routing. They will tell you that beyond this particular latitude, you may face severe weather, restricted visibility, fog, high swell, high waves. So they will recommend you not to go beyond a particular lat. Or if you get this in routing chart will tell you which all areas are dangerous, not safe for the ship to go. So that will help you decide the limiting lat. Okay, so moving ahead, beta.
Sir, this one.
Go ahead.
Sir, when we were crossing the Atlantic Ocean we were going from USA to Europe side, that time we were keeping in the mind we will not cross the 45-degree north latitude because of the ice or bad weather. So I think that is an example for practical.
Exactly, beta. That's right. You are right.
Likewise, we figure out a GC track passing through B again having its vertex in the limiting latitude. So you can see this one. Here is the vertex of this GC track marked with V2. So what is BV2? It's an arc of great circle passing through B, having its vertex in the limiting latitude. Here is the meridian of V2, and obviously this will also make an angle of 90 degrees with the GC track. We get another right angled spherical triangle PV2B shaded out here. Now we get two right angled spherical triangles PV1A and PV2B.
Now, if you look carefully, beta, the third leg of our passage, Victor to Bravo, is again a totally different track. It is not matching with the initial great circle track, pink color great circle track. It is different from that. And it is also different from the blue color track Alpha Victor 1. So it's a totally separate and independent track passing from point B and having its limiting latitude, having its vertex at the limiting latitude.
Vessel moves along this arc of great circle, so this becomes GC track. Vessel also moves from V2 to B, that becomes a GC track. And from V1 to V2, vessel moves along this parallel of latitude so that it does not get crossed, and that becomes a parallel sailing track. So V1 to V2 is parallel sailing track. The vessel's total track from A to B shall have three segments. A to V1, great circle, V1 to V2, parallel sailing, and V2 to B as great circle. Now let's analyze each of these tracks out here. You can see on the screen. Let's analyze track AV1. How do we calculate all these things now?
Now, beta, before we go into calculation, any doubts coming into your mind?
सर ये 90 डिग्री एंगल जो बना है at V1, सर ये दोनों साइड होगा ना 90 डिग्री V के दोनों साइड में सर?
That's right, beta. It will be on both sides.
Okay, sir.
Okay, beta. Great. So we have seen these tracks now, which we are following in composite sailing. We are now going to see how to calculate these tracks, calculate the distances. First, going into track Alpha Victor 1, first leg of our passage.
Now to calculate track AV1 distance and course and other things. Now what is the type of the track AV1? Obviously GC has already explained. We know this side. Why? Because we know the limiting latitude, that is the latitude of V1. We also know this side PA. Why? Because we know the latitude of point A. Now with right angle triangle, two parts known, we can use Napier's rule and we can solve for this angle. It will help us in getting the longitude of V1. We can solve for this arc AV1, that will give us the GC distance between AV1. And in this case, the distance works out to be so much. And we also solve for this angle, which will help us in getting us the initial course when the vessel sets sailing along the GC track AV1 from A. Exactly the same way.
So beta, you see we have applied the Napier's rule in triangle Papa Alpha Victor 1. And using the Napier rule, two parts known to us, we can find out all the other parts of the triangle, giving us these three things where you see question marks made. So angle P is calculated, distance Alpha Victor 1, AV1 is calculated, angle A is also calculated. Angle A helps us to find the initial course exactly as we did in great circle questions using the 1 to 3 method. And distance AV1 is noted down, and angle P which we have got will be used later on. We will be using it later on. So any doubts up to here, beta?
So how we will decide the position of V1 and V2, especially this longitude? Latitude we have at 50 degree, but longitude how we will decide?
You will not decide that, beta. The Napier's rule is going to decide that. You will not be deciding. You don't know what will be their longitudes. This angle P which you have obtained, angle P of this triangle Papa Alpha Victor 1, This is the d long between alpha and vector 1. So when you apply it to the longitude of A, it will give you the longitude of vector 1.
PV1 40 होगा सर?
PV1 will be 40 degrees beta. Limiting latitude is 50. PV1 is colat. 90 minus 50, that's 40.
Okay, sir, good.
Okay, beta. Great. Let's move on to the next triangle, Papa Bravo Victor 2.
We can solve for triangle PV2B for track V2B. We know it's a GC track. We know this because this is the colat of the vertex. This is the colat of point B. And we can solve for now this angle, which shall help us in getting the coordinates of the vertex. We can solve for this V2B arc, which will help us in giving the GC distance on the third leg. And we can also calculate this angle, which shall help us in getting us the final course of the vessel.
So exactly same thing is done with the triangle Papa Bravo Victor 2. It's a right angle triangle. Two parts are known. Papa Victor 2, which is the colat of limiting latitudes. Papa Bravo is known. It is the colat of our destination. So using these two, we calculate the remaining three parts. Out of the remaining three parts, Bravo Victor 2 gives us the great circle distance, third leg of our passage, Victor 2 to Bravo. And angle B will help us to find out the final course, exactly as we did in GC questions using the 1 to 3 technique. And this small angle Papa, we will be using it further. So any doubt up to here, beta?
सर इस कंपोजिट क्वेश्चन में सर हमको एंगल ए एंगल बी सर नहीं निकालना टू चेक वेदर वर्टेक्स लाई इनसाइड और आउटसाइड सर?
बेटा there could be some questions जिनमें ये चीज यूज हो, ओके, बट आपको स्टार्ट ऐसे ही करना है. आपको एंगल ए और एंगल बी पहले नहीं निकालना है. अगर क्वेश्चन में दिया गया है कि कॉम्पोजिट सेलिंग है तो आप ये अज्यूम करके चलोगे कि वर्टेक्स बीच में ही आ रहे हैं. अगर बाद में पता चले कि वर्टेक्स बीच में नहीं आ रहा है तो मैं आपको बताऊंगा उस केस में क्या करना है. वी विल स्विच ओवर टू जीसी इन दैट केस. मैं वो क्वेश्चन आपके साथ करूंगा.
ओके सर, बिकॉज यहाँ पे तो डायग्राम से दिख रहा है हमको ना ऐसा सर्कल बना कि अंदर ही आएगा सर.
I will tell you where it comes outside. How will you find out? I'll tell you.
Okay, sir.
Right, beta. So we are moving on to the third triangle now.
Now, we also know that this angle at P, this angle at P is the D long between A and B. Now, knowing this full angle and also knowing these two small angles calculated while solving the right angle triangle, we can get this angle, which is the D long between V1 and V2. Now, knowing the D long between V1 and V2 and knowing the latitude along which parallel sailing is being executed, we can calculate the distance V1, V2 by parallel sailing formula.
So we have calculated the distance Victor 1, Victor 2 using the parallel sailing formula. Departure is equal to D long into cos of M lat, or in this case cos of limiting lat. So is this part okay, beta? Understood?
One doubt, sir. The V2 also will be same limiting latitude, right? V1, V2.
That's right, beta. Both will be on the same limiting lat.
And sir, is there any chance, suppose after finding out the initial course and final course, and suppose both of them are at acute angles? Sorry, one is acute and one is obtuse. Any such case is there?
Yeah, that case is there, beta. I will tell you later on after we complete a basic problem. I will tell you later on how to do that type of question.
Sir, in this track V1, V2, course will be always 90 degrees. sir, east-west.
That's right, beta. In this case, we are going eastwards, so course will be 090. If we are moving westwards, the course will be 270. Only two courses can be there between V1 and V2.
And how we are calculating the distance, sir? Just I forget the previous one.
Distance between V1 V2 beta.
Yes, sir.
बेटा डिपार्चर इज द डिस्टेंस. हमने अभी डिपार्चर का फॉर्मूला देखा ना. डिपार्चर इज इक्वल टू डी लॉन्ग इनटू कॉस ऑफ एम लैट.
Okay, sir. Departure is the distance. Okay, sir.
That departure is the distance. Great, beta. So we are moving ahead now. We saw a basic question here. So let us proceed ahead.
Sir, but when we will use this departure formula or DMP formula?
Beta, you are not using any DMP formula here. Only departure formula. DMP formula is not used in parallel sailing.
Confuse कर रहा है यार.
When you are doing parallel sailing, the DLAT is 0, DMP is also 0. No DMP is required.
Okay, sir. Thank you.
Okay, beta. Great. Let's go.
X then solved out here, and this sort of sailing, wherein we use combination of more than one sailing, is called as composite sailing. And in this case, the composite sailing involves great circle sailing plus the parallel sailing. Let's quickly summarize the key points of our discussion. Composite sailing comprises of combination of great circle sailing and parallel sailing. The highest latitude not to be exceeded by vessel during a voyage is called as limiting latitude. Reasons that could necessitate limiting latitude during a voyage could include, amongst others, great circle track passing over non-navigable waters, weather routing advice to avoid high latitudes, or ice conditions in the high latitudes.
So this is what we already discussed. Same is being repeated again.
So if there are reasons to limit the latitude, then to strike a balance between the shortest distance and a safe track, we could use this, what we have called as the composite sailing. Having discussed the concept of composite sailing, now we list down certain steps which shall facilitate in making of the diagram and solving the problems related to composite sailing. We first plot the departure and arrival position in correct relative orientation to each other, and the same care needs to be exercised what we learned when we learned to make the PAV triangle. Here is position A and here is position B. Then we identify the appropriate pole. The pole of the hemisphere in which the limiting latitude lies would be the appropriate pole. Then we draw the meridians of A and B. Now, if it was a GC problem, we would have drawn the GC track from A to B, but in this case, we will mark off the limiting latitude. And the red one in the diagram is now the limiting latitude. Next is we draw a GC track passing through A with its vertex in the limiting latitude, the way the green track has been drawn. And here is the vertex of this track, V1. Likewise, we draw a track between B and limiting latitude with the vertex in the limiting latitude, and V2 is the vertex of that track. Now this entire track from A to B has three stretches. One is A to V1, which is GC track, V2 to B, again a GC track, and V1 to V2, rump line sailing along the limiting latitude. Now we can draw the meridians of V1 and V2. Angle at V1 would be 90, and likewise angle at V2 would also be 90. Now we get two right angled spherical triangles. One is PV1A, other is PV2B, which we can solve using our Napier's rules. Now let us first mark the parts which we can figure out from the information that may be contained in the question. Now this is the colet of A. I'm sure all of us can calculate knowing the latitude of A. Likewise, this would be the colet of B. Then this will be the colet of V1. Now, since you know that V1 lies in the limiting latitude, so you know the latitude of V1 and V2, and hence you can calculate PV1 and also PV2. The longitude of A and longitude of B shall give us this angle, which is the D long between A and B. So this angle is also obtainable. Now, having identified the parts which we may know, we can use Napier's rule to calculate which all parts. Let us mark them also. We can calculate this angle. This will be the D long between A and V1. So knowing the longitude of A, we can use this D long and get the longitude of V1, whose latitude is already known to us. Then we can solve for this angle at A, and this angle shall help us in getting the initial course of this GC track AV1. We can also solve it for this side AV1, and this shall be the GC distance between AV1. Likewise, we can solve triangle PV2B. This angle will be the D long between V2 and B. Knowing the longitude of B, we can get the longitude of V2, whose latitude is already known to us. We can solve for angle B, which will help us in figuring out the final course when the vessel reaches B along the GC track V2 to B. We can also calculate side V2B, which will be the GC distance on this last leg of the voyage. Now, having known this full angle, having known these two angles, now this angle can also be obtained. This will be D long between V1 and V2. Now, when we know the D long between V1 and V2, and we also know the latitude, we can calculate by parallel sailing formula the distance along this track. That will be the rhumb line distance, and this way we'll be able to get the total distance, which will be sum total of all the three legs. We shall be able to get the initial course, and we shall be able to get the final course as well.
Okay, beta. Now you have the summary of the total procedure right from beginning to end. This is what we will be following in a normal composite sailing question. So any doubt coming at any stage, beta, please share with me.
Sir, this value of angle A, if we calculate from triangle PAV1 using Napier's law, it is coming like some value it is coming. But when we assume that A to B is a complete great circular track, then if we use cosine formula, then the value of A is coming different, sir.
It will come different, beta, because the great circle track which we were following in GC sailing and this track AV1 are different tracks. When you are going in different tracks, your course will be different. So angle A will also be different, beta.
Okay, sir.
Right. Any more doubt coming in, beta?
सर बाय नेपियर रूल वाले से निकालना है वो हमको सर यूज करना है अंगल वो मानना है ना सर?
हाँ बेटा, इसमें तो हमने कोसाइन फार्मूला लगाया ही नहीं है कहीं, इसमें तो नेपियर रूल ही लगा के निकाला है. कोसाइन फार्मूला तो जीसी के क्वेश्चन में लगाना है बेटा.
हाँ जी सर. ओके सर.
Right.
So generally, sir, while solving the composite circuit sailing, so we don't need to use the cosine formula, right?
No, not required, beta. We do not use. Do not use the.
कंपेयर डिस्टेंस को तो हमको सर वो बाय कोसाइन से डिस्टेंस निकालना है, जीसी डिस्टेंस सर.
Okay. Now, if a question says you have to compare the GC distance with composite distance, फिर आपको GC sailing भी solve करना पड़ेगा, वो cosine formula से solve होगा. आपको composite track भी solve करना पड़ेगा, वो नेपियर रूल से इस मेथड से solve होगा, और फिर आप उन दोनों को compare करोगे.
But sir, initial and final course will be from Napier rule, right, sir?
Whatever they ask, beta. अगर क्वेश्चन में उन्होंने जीसी ट्रैक पे इनिशियल फाइनल कोर्स पूछा है तो कोसाइन फार्मूला से निकालेंगे, और अगर उन्होंने कॉम्पोजिट में इनिशियल फाइनल कोर्सेज पूछे हैं तो हम नेपियर से निकालेंगे।
ओके सर।
So we'll be using a right-angled spherical triangle, right, in the Napier rules.
That's right, beta. These are right-angled spherical triangle.
Perfect.
Great, beta. Shall we move ahead now?
Sir.
Bolo ji.
Sir, for the calculating the angle P between this triangle P, V1, V2, so we'll minus from this total D long like between the A and B.
That's right, बेटा। देखो हमारे पास बेटा इनिशियल और फाइनल लॉन्जिट्यूड्स हैं, उनका डी लॉन्ग अगर हम निकालेंगे तो हमारे पास ये टोटल एंगल P आएगा, विच इज अल्फा पापा ब्रेवो, करेक्ट?
यस सर।
हमने छोटा वाला एंगल P दैट इज अल्फा पापा विक्टर 1 पहली ट्राइंगल से निकाला है, और जो हमारी थर्ड ट्राइंगल थी उसमें हमने निकाला है ब्रेवो पापा विक्टर 2। सो ये दोनों साइड वाले छोटे एंगल P हमें पता चल गए हैं। अब बड़े वाले एंगल P में से दोनों छोटे एंगल P जब सब्ट्रैक्ट करेंगे तो हमारे पास मिडल एंगल P आ जाएगा, विच इज विक्टर 1 पापा विक्टर 2। This is the D long between Victor 1 and Victor 2. Right, beta?
Yes.
Very good. Let's move
So
ahead
sir, if
then.
we know both the longitude of V1 and V2, then also we can calculate angle P. Right?
Yes, beta. You can do that also. आप V1 और V2 के longitudes निकाल लीजिए और फिर वहां से D long निकाल सकते हैं. It will involve one more step, half a minute more, but yes, all that is also correct.
No, if they will ask for the longitude, then this is the easy way, right, sir?
That's right, beta. That's right. Okay, beta. Moving ahead now.
Having understood the concept of composite sailing, let us now solve a question. Calculate the initial course, final course, and distance along the composite track from 37 degrees 40 minutes north, 141 degrees east to 36 degrees 48 minutes north, 122 degrees 40 minutes west with a limiting latitude of 42 degrees north. Now the first and foremost thing is to make appropriate diagram. So we mark off departure position A. Now in relation.
So beta, can you tell me we are moving in which direction? Are we moving easterly or westerly?
It will be easterly, sir.
Easterly, sir.
Easterly.
Very good, beta. So we are moving easterly, so we go on the right side. Very good.
In addition to this, we mark off arrival position B, which shall be to the east of A and slightly to south. It comes on the screen. Now we mark off the appropriate pole, as the limiting latitude is north. So the appropriate pole is north, up on the screen. Now we draw the meridians of A and B. They also show up on the screen. Now if we had to take a great circle track from A to B, we would have drawn the arc of great circle passing through A and B. But in this case, we have a limiting latitude of 42 degrees north. So we draw the limiting latitude, as you can see in the diagram, 42 degrees north. Now we draw an arc of great circle passing through A with.
Go ahead, beta.
Can you please, sir, again explain this, how we are moving easterly? Can you calculate this and tell me?
Sure, beta. Just a minute. Beta, had you done the D long calculation which I showed you?
Yes, sir.
So didn't you get easterly longitude?
Sir, I got confused, sir.
No problem. I'll do it here, beta. See, we are going from 141 east, right? and we are going to 122 west. 122 west. Okay, just leave the minutes for clarity. So 141 east to 122 west. The longitudes are of opposite names. Whenever they are of opposite names, they are added up to get the D long. So when you add them, what is the D long which you are getting, beta?
263.
Very good. So the D long which you are getting is 263. And you are going from east to west. So what is the direction?
Yeah, westerly, sir.
East to west, the direction would be westerly. Now this value is coming more than 180. If it comes more than 180, what do we do?
So subtract it from 360.
Very good. So you subtract it from 360. It basically gives you 97. And along with that, what do you do with the name?
Opposite name.
So you get a D long of 97 degrees east, right, beta?
Yes, sir. Okay, sir. Got it. Thank you.
Great. Let's go back to the video.
Its vertex at the limiting latitude. You can see with vertex at V1, the green part. Likewise, we draw another arc of great circle passing through B with vertex at the limiting latitude and the vertex being V2. Now the vessel shall be moving along the track A to V1, which shall be a great circle track, V1 to V2 along a rhumb line track, and V2 to B along a great circle track, completing our voyage from A to B. Now we draw the meridian of V1, angle at V1 is 90. We draw the meridian of V2, angle at V2 is 90. Now we mark off parts that we can calculate. Now PA, we all know, is colat of A, and value is 52 degrees 20 minutes. Then PV1 is the colat of V1. Now V1 and V2 both lie in the limiting latitude, so their latitude is 42 degrees north. Therefore PV1 is 48 degrees. Likewise PV2 is also 48 degrees. Now PB would be the colat of B, and value is 53 degrees 12 minutes. The longitude of A and B give us this angle at the pole, which is the D long between A and B, and this value is 96 degrees 20 minutes. So now what we have done is we have marked the parts which are available to us.
So any doubt up to here, beta?
Oh, sir, it's going okay.
Very good.
And using the two right angle triangles, now let us also identify what all are we going to calculate. We can calculate this angle. This will be D long between meridian of A and meridian of V1, and that can help us in finding the longitude of V1, whose latitude is already known. We can calculate these angles also. This angle will help us to calculate the longitude of V2, having known the longitude of B. Now this full angle is known to us, 96 degrees 20 minutes. So this angle can also be calculated. So all these three angles at P, we will be able to calculate. We can also calculate angle A, and this shall help us in giving the initial course when the vessel sets sailing on this GC track at A. We can also calculate angle B, and this shall help us in getting the final course of the vessel. We can get this distance A to V1, distance V1 to V2, and distance V2 to B. All these added together shall give us the total voyage distance. So now we solve the two right angle triangles to find the missing parts. We first deal with triangle PV1A, and this triangle in the diagram is shaded for easy identification. It is this triangle we are talking about. We make the Napier's cartwheel with V1 being 90. I'm sure as the cartwheel is being completed, you can also revise with it. So there the cartwheel gets completed. Now in the cartwheel, we identify the parts that are known to us. What we know is PA and PV, so they get identified in the cartwheel. Other three parts we can calculate using Napier's rule, so they come up with question marks. Now we can apply the Napier's rule. We can first apply for AV1. Sine of the middle part is equal to product of the cosines of the opposite. When we put the values, we get AV1 is equal to 24.045 degrees, which multiplied by 60 becomes 1442.7 nautical miles. That is the GC distance from A to V1, and this distance we transfer to the diagram here. Now we write the formula for angle P of the triangle. So sine of the middle part is equal to product of the tangent of the adjacents. We put the values and we get the value of P as 30 degrees, 58.8 minutes. It's transferred here. Now this is the D long between A and V1. So if the question wanted the coordinates of V1, then we could have found the longitude of V1 by applying this D long to the longitude of position A. However, since it's not required, so we are skipping it and we write the formula again now. And obviously this time we want to calculate angle A. So sine of the middle part is equal to product of the cosines of the opposite. When we put these values, we get angle A as 69 degrees, 51.2 minutes. This value we transfer to the diagram here.
So beta, we have applied the Napier rule to the first triangle, Papa Alpha Victor 1. So have a look here. The Napier rule is there. Any doubt you are having, let me know, beta.
The initial course will be same, right? Because northeast quadrant, right?
That's right, beta. If you apply the 1 to 3 method, initial course is going to be the same, 069 degrees, 51.2 minutes true.
Perfect, thank you.
Okay, beta, great. Shall we move on to the next triangle?
Yes, sir.
Very good.
Now we can solve the triangle PV2B to find the missing parts therein. The triangle is shaded, so this is the triangle in question. So we first make the cartwheel for right angled triangle, right angled at V2. So this is the cartwheel with V2 being 90 and other parts being filled in the cartwheel clockwise from V2. Now we identify the known parts. Known parts are PV2 and PB. So PV2 and PB are known to us. Other three can be calculated. So we have question mark out there. Now we apply Napier's rule. First we can calculate BV2. And when we put the values, we get BV2 as 26.462 degrees, which is 1587.7 nautical miles. And this distance we put up on the diagram here. So the distance on the GC track from V2 to B is 1587.7 nautical miles. Now we write down the formula for angle P of the triangle. So here is the formula, product of the tangent of the adjacents. Put the values. Angle P comes to 33 degrees, 58.9 minutes, and the value of the P goes into the diagram. Again, had the longitude of V2 been asked for, we could have applied this D long to the longitude of B to get the longitude of V2. Not required, so not being calculated. Now we write the formula for getting angle B in the triangle. product of the cosines of the opposite. And when we put the values, we get B is equal to 68 degrees, 08.3 minutes. The value comes out here in the diagram. So now we have calculated all the three parts of the triangle PV2B.
So beta, Napier rule applied to the triangle Papa Bravo Victor 2. So just have a look. Any doubts coming in, please share with me.
Sir, the position of the vertexes will be latitude 40 degree north and the respective longitudes, right?
That's right, beta. The latitude would be 42 degrees north, which is our limiting latitude, and longitude can be obtained. See, we have these angle P now. When you apply this angle P to Bravo and Alpha, you can get the longitude of Victor 2 and Victor 1.
Okay, sir.
Sir.
Bolo beta.
Sir, while doing question this in the paper, sir, so we'll be doing like same sequence, like first triangle this, and after that the second triangle. Not like we will do first V1 a triangle, then we will do this plane and parallel sailing, and then we will do the this next triangle.
बेटा you can do as comfortable to you. आप कोई भी triangle पहले और बाद में कर सकते हो. There is no issue.
Okay.
तुम लोग हो जाओ 8 बजे तक होगी मेरी क्लास. तुम लोग हो जाओ. तुम दोनों जाओगे क्या? तुम लोग जाओगे? नहीं.
ओके बेटा, जब आप मिडल ट्रायंगल सॉल्व करोगे ना, मिडल ट्रायंगल पापा विक्टर 1 विक्टर 2, तो मिडल ट्रायंगल के लिए आपको एंगल P चाहिए. वो तभी मिलेगा जब आपकी दोनों साइड वाली ट्रायंगल सॉल्व हो जाएंगी. सो आप पापा विक्टर 1 विक्टर 2 को पहले सॉल्व नहीं कर सकते हैं, राइट?
ओके सर, थैंक यू.
राइट.
So can you confirm the final course is 180 minus B?
That's right, beta. That's right. I'll show you here also 1, 2, 3 method, but you are right, 180 minus B.
So now, if you see in this diagram, there are only 2 question marks left. Rest of the unknowns have already been calculated and filled in. One is this angle. Now, since we know this angle, we know these 2 angles now, so this angle can be easily found. So now angle APB is 96 degrees 20 minutes. The other 2 angles are known to us, and this way we get angle V1PB2, that is this angle, as 31 degrees 22.3 minutes, and this value goes into the diagram. So now only missing part is this rhumb line distance. Now we know this 31 degrees 22.3 minutes is the D long between V1 and V2. Also, the vessel is doing rhumb line along 42 degrees north. So this distance shall be corresponding departure in this latitude. So by parallel sailing formula, we know this cos V1 V2 will be equal to D long into cos of limiting latitude 42 degrees. When we put the value, we get distance V1 V2 as 23 degrees 18.8 minutes, which is equal to 1398.8 nautical miles. So we get the distance V1 V2 using the formula cos lat is equal to departure upon D long. This distance goes into the diagram. Now everything in the diagram has been calculated, whatever was missing. So whatever was earlier known is shaded with green ticks. Whatever has been calculated is indicated by these yellow highlighted values in the diagram. Now let's come to summarizing of the answer now. Now the composite track distance from A to B shall be sum total of these 3 distances, and you can see that comes to 4429.2 nautical miles. The second requirement of the question was the initial course. So let's go to the diagram and mark out, place a vessel as she would be heading at A. Now, as explained in the earlier videos, let's mark off the initial course clockwise from true north at A. This arrow represents the true initial course. Now we can see clearly that angle A that we calculated is directly equal to the initial course. So therefore, initial course is equal to angle A expressed in three-figure notation, 069 degrees, 51.2 minutes, true. Now to get the final course, let's place the vessel as it would be as it reaches B. The vessel would be as this. Now clockwise from true north at B up to the ship's head, let's mark off the final course. This represents the final course here. Angle B calculated is this one, and we can see final course will be 180 minus angle B, and that's how we can get a final course, that is 180 minus angle B. The final course is 111 degrees, 51.7 minutes true. And this way we get all that was asked from us to be solved in this particular question.
So have a good look, beta, and let me know any doubts coming in.
Excuse me, sir.
Sir, departure is equal
I
to.
think there's a
Go ahead, beta. Departure is equal to.
So departure is d log into cos let. No, sir, I cannot understand why this cos v1 v2. This is directly departure, no?
Oh, that's right, beta. This cos is a mistyping here. V1, V2 is equal to d long into cos of lat.
Okay, okay, sir. Thank you.
in the first step also, sir, instead of VP, V1, it should be VP, V2, right? While doing the minus in the first step.
APB minus alpha papa Victor 1, Bravo papa Victor 2. That's right, beta. You are right. This should be Bravo papa Victor 2. That's correct.
Okay, thank you.
Can you please tell once again how to calculate the D long?
How to calculate the D long between vertex 1 and vertex 2, right?
Yes, sir, correct.
Okay. Beta, this total angle, the maroon color angle from A to B at the pole is 96 degree 20 minutes. Agree?
Yes, sir.
Now the smaller angle alpha papa Victor 1 is 3058.8. We calculated it by Napier. Agree?
Yes, sir.
Now coming to triangle Bravo Papa Victor 2. This angle Bravo Papa Victor 2 is 3358.9. We calculated it by Napier's, right?
Yes, sir.
So you have the total angle 9620. If you subtract these two side angles, small angle P, alpha Papa Victor 1, Bravo Papa Victor 2, you will get the middle angle.
Sure. Yes, sir. Thank you. Got it, sir.
Very good, beta. So any more doubt, beta?
Excuse me, sir.
बोलो जी.
सर क्या हम ट्रायंगल टी V1 V2 को क्या कोसाइन रूल से सॉल्व कर सकते हैं या वो गलत तरीका है?
ना बेटा, ना 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 ना, बिल्कुल नहीं करना. रीजन इज कि ये जो ट्रायंगल है बीच वाली पापा विक्टर 1 विक्टर 2, दिस इज नॉट ए स्फेरिकल ट्रायंगल. व्हाई? बिकॉज विक्टर 1 विक्टर 2 is a small circle. It is parallel of latitude 42 degrees north. It is a small circle, cannot apply spherical trigonometry.
Okay, sir. Thank you, sir.
Okay, so don't use Napier for the middle triangle or cosine formula for the middle triangle, cannot use.
Okay, thank you, sir.
Very good, beta. So all sorted out, beta? All clear?
Yes, sir.
All clear, sir. All clear.
Sir, one doubt, sir.
Just
now, sir, you told that, we can't apply the cosine and Napier's on that small triangle because that V1, V2 arc is a straight line, right? It is. It doesn't mean that it is a great circle. If there is a great circle, we can apply, right? What is the difference of the small circle and great circle on that basis?
Right, beta, right. A great circle is having its plane passing through the center of the sphere. So equator is a great circle, but all other parallels of latitude, their plane does not pass from the center of the earth, so they are all small circles. Now this V1, V2 is 42 degrees parallel of latitude, so that's a small circle, beta.
Okay, sir. Thank you, sir. I understood. Thank you.
Okay.
Sir, this angle V2B, V2PB, it is coming 48.9, sir. Can you confirm?
Which angle, beta? Vector 2 Papa Bravo?
V2, correct, sir. 3348.9.
Yeah, that is possible, beta. I remember there was a typo error here in this question. So that's possible. 38, 48.33, 48.9 you are getting.
Yes, sir.
Yeah, what I remember is that it was like that only. But other people can also calculate and then you can match it with them. But I believe there was a mistake.
Okay, sir. Thank you.
Great, beta. So I hope that is clear now. So if you are comfortable, shall I close out the presentation?
Yes, sir.
Yes, sir.
Very good, beta. Great. Okay, beta. So that explains how we attempt a composite sailing kind of question. We have done a basic questions. अब बेटा इन composite questions में एक tricky concept कभी कभी आता है. So वो tricky concept मैं अब आपको कराऊंगा. But before that, you can take a small break. Let us take a 10 minutes break or so that this gets settled down in your mind. Okay. So then I will do the tricky question in composite sailing. And then after that tricky question is done, then we are done with composite. फिर मैं बेटा simple topic pick up करूंगा. That is plane and parallel sailing and Mercator sailing. Right? So we can meet back after 10 minutes.
Okay.
Yes, sir.
Okay, it's about 48 now. Let's meet at 58.
Okay, sir.
Okay.
Sir, excuse me. Sir, I have one request. Can you leave 10 minutes before 2000 because I have to take a train today and I have to leave by 2000 if it's possible.
Okay.
Just
No
10
problem,
minutes
beta.
before 2000, sir. Okay, thank you.
No issues. No issues. We'll do that. We'll do that. Don't worry.
Okay, sir. Thank you.
Hello, beta. Welcome back.
Yes, sir.
Okay, beta. So we have done a basic composite sailing question. Now we will see sometime the question involves a little bit of trick. So let me show you what kind of trick is made in the question and how it is to be attempted. So let me set up the presentation. Now, having understood a basic composite sailing problem, let's look into a typical kind of problem which sometime comes in exams related to composite sailing concept. Now, in these type of questions, the limiting latitude matches with the latitude of either the initial position or the final position. Till now in the examples we have seen that the limiting latitude is higher than the latitude of starting position as well as the destination. But if in case the limiting latitude matches with the latitude of initial position or the final position, how do we approach this type of question? Let's make a diagram here and try to understand first what the question is and then how do we solve it. Let's assume the vessel's initial position is here. We mark this position as A. This is the initial position of the ship. Let's assume that the final position of the ship is at this particular location. We mark this position as B and go ahead, beta.
Sir, I just connected now, sir. Just right now I connected. From starting this, I didn't hear, sir, what you started, sir. Could you repeat it again, sir, from starting?
No problem, beta. You did not miss anything. I am just starting to write the question. You will get to know it.
Okay, sir.
Okay, beta. Okay. And, this is our destination or final position. Let's now complete the plot. Let's put in the pole also and try to make the composite sailing diagram. Now in these problems, the limiting latitude matches with latitude of one of the ports. So in this particular case, B being at a higher latitude, we are in the northern hemisphere. B being at a higher latitude, the limiting latitude exactly matches with the latitude of B. So this tells us that if we plot or draw the limiting latitude, it will be passing from our final position B, and that's what you can see in the diagram now. Let's now plot the pole. You can see the pole P plotted in the diagram. Now from the pole, let's draw the meridian of A. So PA represents the meridian of A, one of the sides of our diagram. Let's plot the meridian of our final position also now. So PB is the meridian of B. Beta, any doubt up to here?
No, sir.
No.
Okay, beta. Okay, all right. Now in composite sailing problems, the first course is found by making a great circle track. The great circle track should be such that it passes from our initial position, in this case A, and it has its vertex on the limiting latitude. So we will first plot this great circle track exactly like this. It will pass from position A, that is our initial position, and the track has its vertex on the limiting latitude. So you can see the first great circle track in the plot now. As you can see, it passes from the initial position and it has its vertex on the limiting latitude. So that's the limiting latitude is the highest latitude where this great circle track would go. Now the point where it meets the limiting latitude is the vertex of this particular track, and we mark off this vertex as V1. As usual, we mark off this vertex as V1. Now once we reach at this vertex V1, we then proceed on our second leg of the passage. The second leg of the passage is a parallel track. We move along the parallel of the latitude on our limiting latitude itself. Now when you move along the parallel of the latitude, or which will be the limiting latitude in this case, you will see the port B final position being at the limiting latitude. When you move on this parallel track, you will arrive at your destination. So you see, in this case, we do not have to follow the third leg of our passage. That is the great circle track from limiting latitude going up to position B. That is not required at all, because when we are following our second leg of the passage, that is moving along the parallel track, we will be reaching to our destination, that is position B, because the destination is exactly on the limiting latitude. Now let's complete the diagram. Let's mark off the meridian of vertex 1 also. So you can see the meridian of vertex 1 marked on the plot. PV1 is the meridian of our vertex. So green color track is the GC track passing from position A and having its vertex at limiting latitude. The red color track V1B is the rump line track from the vertex 1, which takes us to our final position B. So we have the diagram completed on the screen now. Now in this diagram, we now have two triangles being formed. In a basic composite sailing problem, we saw there were three triangles which were being formed. But in this case, there are only two triangles which are being formed. And out of these two, one of the triangles is a spherical triangle. The two triangles being formed are PAV1 and the second one is PBV1. And out of them, the spherical triangle is the PAV1 triangle. So it's a spherical triangle, and not only that, it's a special spherical triangle because we have a right angle at vertex 1. At vertex, the great circle track runs in east-west direction, that is 090270 direction, and it is at right angles to the meridian which runs in the north-south direction. So angle V1 here is a right angle, and triangle PAV1 is a spherical triangle. So the PAV1 triangle is checked. This is the spherical triangle which we have. The second triangle Papa Bravo Victor 1 PBV1 is not a spherical triangle because the side BV1 is not a great circle. It's a small circle. All parallels of latitude other than the equator are small circles. So the limiting latitude which we have as side BV1 is a small circle. So that tells us that this triangle is not a spherical triangle. So now we have identified the spherical triangle. Let's see how do we solve it. The solution is quite similar to the one which we had done earlier. We will first solve the spherical triangle PAV1 using the Napier's rule. Now Napier rule says that using the Napier's rule, we can solve the triangle PAV1. The Napier rule says that in a right angle triangle, if we know any two parts of the triangle other than the speciality, the 90-degree angle or 90-degree side, other than the 90-degree angle or 90-degree side, if any two parts of the triangle are known, using the Napier rule, we can find out any other missing part of the triangle. So let's identify the two known parts. The first part which is known to us is PA side. PA side is the colat of our starting position A, 90 minus latitude of A. The second part which is known to us in this triangle is side PV1. Side PV1 is the colat of our limiting latitude. The limiting latitude is given to us in these questions. So it is 90 minus limiting latitude. So with these two parts, we enter into the Napier's rule. And what do we find out? The first thing which we find out is angle P of this triangle. Angle P of triangle PAV1. Now this angle is the angle at the pole contained between the meridian of A and the meridian of vertex 1. So this gives us the D long between A and V1. Now as soon as we have this D long, we can apply this D long to the longitude of A, which is our initial position. The lat long of initial position is provided to us. As you apply this D long to longitude of A, it gives you the longitude of the vertex 1. So angle P, as it is known, applied to the longitude of A gives us the longitude of vertex 1. Now when we get the longitude of vertex 1, we are now able to easily calculate the run line distance, Bravo Victor 1 also. We have the longitude of vertex 1 known to us. We have the longitude of our destination position B, final position B. So we can calculate the D long between B and V1. So this D long is used in the parallel sailing formula to calculate the departure between B and V1, and it gives us the run line distance Bravo Victor 1 using parallel sailing. Coming back to the first triangle PAV1, now the next thing which we find